So obviously the question was, where does it come from? It comes from everywhere. We speak, we move, sensors, computers, documents. Then we had structured and unstructured data, human generated data and machine generated data. We discussed that email generates data, blogs generate data, videos, pictures, etc. Then machine generated data, we have automatic alerts in machines, we have logs, we have sensor data. So this is all the classification of data that we come across, right? So Navneet, can you unmute yourself? Navneet Kaur, unmute yourself. Navneet, can you hear me? Speak up, Navneet. Yes, Navneet, go ahead. Can you hear me?
Yes, sir.
Okay. Could you please tell us, Navneet, what do we understand by logs? We are waiting for a reply from your side, Navneet.
Any activity chart?
Activity chart of what? Shaurya, you can unmute yourself now. Ajay Sharma, you can unmute yourself.
Hello, sir. Hello.
Yes, Shaurya, can you hear me?
Hello. Hello, sir.
Shaurya, can you hear me? I'm not able to hear you, Shaurya. From my side, Shaurya, you are so far, non-participative in this meeting. In the previous also, I can't hear you. There's some problem
Yes,
with the
sir.
device that you are using. You see, you need to rectify that because
Hello,
we
sir.
cannot go with your hand raise all the time. Varisha, unmute yourself.
Yes, sir.
Varisha, Navneet said log is some activity chart. Is that correct?
Yes, sir. It is an activity charge of some process.
Some process. That's more
Yes,
important,
sir.
right? So
Yes, sir.
what all is there in the activity chart?
Like, like we log in and log out now.
Okay.
That type of an activity chart it is.
All right. Nancy, can you unmute yourself now? Nancy, unmute yourself. Nancy is not there, I suppose. Okay.
Yes, sir.
Nancy, could you please tell us what is a log and why it is so important in big data analytics? Okay. So Ritika, unmute yourself.
An activity.
Yes,
Yes, sir.
Ritika, please answer.
So log is any activity chart of a particular session or the activities we perform.
Fine. So let's continue. This initial, discussion, I'm calling you by name so that we get into an interactive mode, and I should not be speaking only because the idea is not to just go through the PPT, but to highlight each and everything that is there in it. And maybe in the later lectures, from third lecture or fourth lecture onwards, we'll be working a lot of practical things. So till the time we reach there, kindly stay focused, all of you. So next thing obviously is what is big data, right? So we defined it as the term for a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. That means we are here defining big data as two things. One, it is huge, and second, it is complex. Okay, and because of these factors, it becomes difficult to process it using whatever tools we have, the traditional tools, the database management systems that we have, the data processing applications that we've been using. So if we use them, we cannot, analyze this huge data. We cannot handle this huge and complex data. Complex simply because it is in different forms. It is unstructured. It is maybe semi-structured. Okay, so there is no fixed structure with it, and with that, it is coming to us at a huge, velocity, great velocity, and the volume is also great. So you remember the three V's: volume, velocity, and variety. All these things make it difficult for us to handle big data using the traditional tools, right? Then we saw that everything that we are, involved in today's real world involves big data. Experiments, research, photo sharing, CCTVs, social network, e-commerce, point of sales, mobiles, everything, everything involves data. And all the more so important, to analyze this data for, the corporates or the multinationals to generate and increase their revenues, right? And increase their customer base. Okay. So the analytics helps them to understand the customer sentiment. Now this data has been rising steadily, but very exponentially. It is increasing, but the increase is exponential, as you can see from this graphic. And herein we also get to know about exabytes, the next unit after petabyte. So if somebody of you can, just tell me what exactly are these terms. So let's ask Ritik. Ritik, can you
Yes, sir.
please tell us what is this exabyte?
So 10 raised to power 25, I think.
अब देखो 9, 12, 15, 3 के मल्टीपल्स में आ रहे हैं 25 तो आएगा नहीं ऋतिक, राइट?
No,
सो
sir, 25.
नो 10 इस पर 25 नहीं
24,
आएगा ना,
sorry, 24.
24 भी नहीं है. So you just try to, some of the types you're already aware of. So try to memorize a few more. Okay. So let's hear from Kushpreet.
KBMB.
Yeah, Kushpreet, can you please tell us what is an exabyte?
Yes, sir. So it's equal to 10 to the 18.
Okay. Louder, Kushpreet. I couldn't hear you. Maybe the mic should be more close to your face.
Yes, sir.
10
Sir,
raised to
it's
power 18 is the correct
yes,
answer.
sir.
Okay. So we also saw like the different ones, the zettabytes, the yottabytes, the xenotabytes. So just to refresh your memory, maybe, I can again bring that graphic in front of you so that you remember what these data types look like, right? So this is the entire, the data sizes chart that we had. EB is exabyte is 10 raised to power 18, zeta is 10 raised to power 21, yotta is 10 raised to power 24, and so on. I think I've sent this file to you, so you just have a good look at it so that you are aware of all these data sizes, the units that data sizes are mentioned in, right? Then we had examples of enormous data. I think you all know it. You all use these, so you are aware of them. Then we decided that the traditional systems that we are working on, they are not able to store this huge data simply because these data, big data files are very big. One file could be at least 1 TB in size. And if you need to, store these files, store this data, manage this data, then huge cost is involved in increasing server capacity. If you want to increase your network capabilities, your storage capabilities, then you need to invest a lot of money. And that is why most of the data in the real world remains unprocessed. And approximately 90% of this data is unstructured. And enterprises are unable to process this data. So what needs to be done? We need to do three things. One, we need to store this huge amounts of data that is being generated nowadays to store properly, to process it properly and quickly, and to analyze it for business enterprise growth. And one solution to this problem is the use of a technology known as Hadoop. Okay. Then we had a historical preview of big data. What was the problems and what white papers were written. So one white paper was Google DFS or Google GFS, so Google File System, and it was in 2003 that this was published. Doug Cutting was working on DFS as well, so he found this solution and named it as Hadoop. Okay, this distributed file system. He named it as Hadoop after his son's toy, name of the son's toy elephant, right? And this was later donated to Apache, which is a free software, society sort of thing, Apache Software Foundation, and it is now a full-fledged project on Apache. The timelines: 2003, the paper was published. 2003, remember, right? Then the next analytics part was there. The data was stored, then it needed to be analyzed. So Google wrote another white paper for it, known as Google MapReduce algorithm, right? And it was again Doug Cutting who made it possible, checked it in the full-fledged production environment of Yahoo, and again it was donated to Apache as a full-fledged project, right? So this was in 2004. So to see the timelines, 2003, Google released a white paper called the Google File System. In 2004, Google released another white paper called MapReduce, Simplified Data Processing on Large Clusters, right? Okay. And in 2006, we had this, Hadoop was born, okay? And it is an open source project under the Apache Software Foundation licensing scheme, right? So this is about the Hadoop and a brief history. Then Apache Software Foundation, it has projects based on meritocracy, right? They are governed by merit, okay. And this Apache Software Foundation is a non-profit organization which was founded in 1999. But today we are having some problems with our license account. So as soon as this meeting ends, another 1-2 minutes you can rejoin on the same link, right? That's clear to all of you. Give me a raised hand. Today we are having some problems with the license account. So yeah, you got it. That we'll be rejoining on the same link, all of you, right? Thank you. Now this is something new. So let's have a good discussion about it, right? This a few slides I've added. You can take screenshots. So what actually is Hadoop? We are saying that Hadoop is used, for analytics, for storage, for processing, right? So let's see what Hadoop is, based on. So Hadoop is a data storage and processing platform based upon a central concept, that is data locality. Okay. So there is one concept known as data locality. People are still raising hands. Anything important? If there's something important, you can raise your hands. Otherwise, you can lower it right now. Okay. I'll be coming to a question answer session after 2 more slides. Okay. Just wait. So data locality means bringing the computation to the data rather than the typical traditional pattern of requesting data from its location. So what we have been doing before Hadoop, we were taking data to some processing application, that this is the data, this needs to be processed. But in Hadoop, data is local. It stays where it is. The computation is brought to it. Okay, and this means data locality. And with this concept, large data sets can be processed locally on the nodes of a cluster using a shared nothing approach. Okay, so cluster, we just had a brief discussion in the previous class that it's a collection of computers in which there is one admin or master machine, and there are slave machines known as commodity machines. We'll again discuss it today in detail, right? And all these nodes, they don't share anything with each other. They can process data on their own, right? So that is why two important concepts here: data locality and shared nothing, right? So each node can independently process a much smaller subset of the entire data set without needing to communicate with one another. So what is the concept of data storage and processing in Hadoop? The data set is first split up and it is distributed across the nodes. Then each node processes data on its own and all the results are then combined together. Right? And while processing the data, nodes don't need to communicate with one another. Another thing, Hadoop is schemaless. As I told you, when it is going to deal with unstructured or semi-structured data, so it is schemaless. Okay, we call it schema on read system, right? And if you go with what you studied in the previous semester, Oracle is schema on write system. What does schema on write or schema on read means? Schema on write, like Oracle is, it means that you need to first have a schema to actually store the data. Data cannot be stored until and unless you create some structure, like the table structure you used to create. You used to give the column names, you used to give the data types, and then you store the data. But here data is there in any shape. It is ready to be analyzed and stored. So Hadoop is schemaless and it is referred to as schema on read system. Whereas your Oracle or the relational databases, they are termed as schema on write systems. Okay, and Hadoop can store and process a wide range of data. So that's what we have been discussing. It can analyze and store, structured, semi-structured, and unstructured data. All types of data it can handle. So that is one of the specialities of Hadoop. So we understand what are schema on read systems versus schema on write systems, right? And NoSQL platforms, money, you need to wait. Just wait for 2 minutes, I'll come to you. NoSQL platforms such as Apache, HBase or Cassandra are classified as schema on read systems. So SQL platforms like Oracle, DB2, they are all schema on write. Whereas NoSQL platforms, NoSQL stands for not only SQL. So there is something, some data storage or processing that you can do without SQL also. So that is termed as NoSQL databases, not only SQL, right? And the examples of NoSQL platforms are Apache, HBase, and Cassandra, and they are also classified as schema on read systems. So because the schema is not interpreted during write operations to Hadoop, there are no indexes, no statistics, or other constructs typically employed by database systems to optimize query operations. While we are running queries in SQL like we did in the previous semester, so a lot of things are there in the background, indexes, statistics, so that our query runs efficiently. We optimize the query, but no such thing is there in Hadoop, right? Because the schema is not interpreted, you can directly start working with the data without having a schema. And that's why Hadoop is designed to find needles in haystacks. That means it can find the minutest detail from your data. That is the meaning of this term, that out of the huge data sets that we have, it can find the minutest detail out of it. And that is simply possible because of its data locality and shared nothing approach. Okay. So now we'll have some questions, and then I think we'll have a next meeting after some time. So Money was there. Yes, Money. Go ahead. Ask your question, please.
सर वो एक्चुअली वो क्या था क्या कहते हैं सर रीड राइट ऑन रीड एंड ऑन राइट का सर वो रिपीट करना.
What do you want to ask in that?
सर एक्चुअली सर आपने टर्म मतलब आप बता रहे थे कुछ सिस्टम का रिलेट कर रहे थे उसको ट्रेडिशनल सिस्टम्स के साथ स्कीमा ऑन द बेसिस ऑफ स्कीमास.
I think I explained very clearly that schema on read systems are those, okay, schema on read means which don't require a schema to process or store data.
Yes.
And schema on write are in which we need the schema first, only then the data can be stored and then it can be analyzed. So your Oracle is schema on write.
Okay, sir.
right? आपने जब Oracle पढ़ी है, you have first created a schema, structure
Yes, sir.
बनाते हैं ना, table बनाते हो, फिर data
Ye-
store करते हो, table में you tell the columns, the types, okay? No such
Yes, sir.
thing is required in Hadoop. That is why it is simply schema on read, whereas Oracle and all the relational databases are termed as schema on write systems.
Okay, sir.
Is
Thank
this
you.
clear?
Yes, yes.
Okay. Any other question? You can raise your hands, please. Any other question? You can raise your hands. We have approximately 2 minutes left for this meeting. I told you we are having some issues with our licensed account today. It will be resolved soon. But till the time, we'll have 40 minutes duration meeting. So this meeting has about 2 minutes left. So if there are any questions, okay, I'll move forward then. This is basically a review and some new concepts in today's lecture, and then in the second meeting we'll start again some fresh topics, right? So this is the Hadoop core components. I told you, remember, Hadoop has two core components. One is the HDFS, which is Hadoop Distributed File System, which is also termed as the storage subsystem of Hadoop. And the second one is the processing or the resource scheduling subsystem, that is known as the Hadoop YARN, yet another resource negotiator. The previous name, the first version was known as MapReduce, and the subsequent versions they are termed as YARN now. So MapReduce and YARN are synonyms, right? New name is YARN, yet another resource negotiator. And each component, HDFS and YAR is independent of each other. They can operate on its own in the cluster. If you combine both this HDFS and YARN, then you call that thing as a Hadoop cluster. Remember, HDF cluster and Hadoop cluster, HDFS cluster and a YARN cluster can operate independently. When they are together, co-located, then you call it a Hadoop cluster. Okay, and individual machines in a server are known as nodes. Then we have Hadoop ecosystem projects. You can see on screen, right? Data analysis projects, data ingestion, then NoSQL databases, and the security, right? So I'm stopping this meeting. We can join again in 2 minutes time, right? So let's now discuss the commercial Hadoop landscape. We discussed this in the previous class also. So just to have a quick revision. Although we know that Hadoop is an open source project under Apache, but there are many commercial vendors also, right? So the first commercial, Hadoop software was the Cloudera, right? It was called the Cloudera distribution of Hadoop. Now there are two types of vendors, Hadoop vendors. One, they are known as pure play Hadoop vendors. We call them pure play because their business models are based upon Hadoop in totality, right? And there are many other vendors whose main, business model or core business model is not Hadoop. So they come under the Open Data Platform Initiative. They are the ODPI members. Okay. So these ODPI members are IBM, Pivotal, Teradata, etc. Right. And this was formed. ODPI was formed. The reason for its formation was to provide a consistent commercial ready set of Hadoop core and selected ecosystem components. Since it is not based totally on Hadoop, so there are selected ecosystem components in it, right? So you can see the classification here. Pure play Hadoop vendors are Hortonworks, Cloudera, MapR. Whereas you can see a large number of ODPI members. Remember, ODPI members are those whose core business is not Hadoop. They use Hadoop, selected Hadoop ecosystem components. Now, important thing, typical Hadoop use cases, that is the areas where Hadoop is used. So as we discussed in our previous section, in our previous class, that three typical Hadoop use cases are what you see on the screen right now. One is the data warehouse, ETL process. Then second is the event and complex event processing. And the third one is data mining and machine learning, which we also call as advanced analytics, right? So data warehouse offload, the most common use of Hadoop is this, in which data is picked up from data warehouses. A data warehouse is where you store a huge amounts of data, just like a warehouse at your home. You store a lot of junk things there. So similarly, in a data warehouse, there is a lot of data which has been collected over a period of time. And if you need to analyze it using Hadoop, you must first bring it to Hadoop and go through the ETL routines, that is the extract, transform, and load. Okay, and the advantage of Hadoop, for this data warehouse analyzing of data is that the lower storage cost and lower processing cost. That is one big advantage of Hadoop. That to store data or to process data, the cost is much less as compared to other systems. So if we discuss of MPP platforms such as Teradata or Oracle Exadata, they give you a lot of cost, maybe 10-20 times the cost of Hadoop if you need to store and process the data using these facilities, right? So if I may ask somebody, yeah, let's see, let's ask Raju Kumar. Unmute yourself, Raju.
Yes, sir.
Raju, what is this MPP platform? Can you see here? Specialized MPP platforms. See the last bullet, right? What is this MPP,
Yes.
Raju?
Sir, MPP, I think some related to high command data.
Is it related to?
So it
Yeah,
is
go ahead.
related, sir, related to some data, sir.
Okay, not exact answer. Prince, can you please unmute yourself?
Yes, sir.
Yeah, Prince, what is this MPP platforms? Can you please suggest?
Sir, massively parallel processing platform. Hello.
Yes, go ahead.
Sir, sir, massively parallel processing platform.
Yeah, massively parallel processing platforms. This term is for, these Teradata and Oracle Exadata, they come under massively, parallel processing platforms. So the cost of data storage and data processing is huge in these. A good answer, Prince.
Yes, sir.
I said good answer. Great. Okay, let's now see the event processing. Event processing usually, is when you pick up a lot of data from various sources, from streaming data sources, message data, tweets data, log data. Okay, so when you just bring it for analysis, then this is termed as event processing. And once again, the advantage with Hadoop is low cost and low computational cost, right? And it can mine huge volumes of data to identify patterns out of it and predict something. The third thing, as all of you know, the very important area of machine learning. So it is termed as advanced analytics. Okay? It is the process of identifying patterns in data and building mathematical models. So what we do is first we identify that this data, this particular set of data is giving these signals. These are the patterns. And then you build a model on it, a predictive model. And then you predict what will happen to the subsequent data that comes after it. So that is the basis for your machine learning concept. So Hadoop, acts as the first stage of your machine learning, wherein you are able to process and analyze huge amounts of data, and then you are ready for predicting that data, right? Any questions? If there are any questions at this point, I would be, more than happy to answer. You can raise your hands if there are any questions in these 3 slides. That is the typical Hadoop use cases. I think they are clear. All right. So let's go ahead. This I'll just skip through. You remember? Yeah, I'll just flash this slide in front of you. You remember that to store these huge big data files, we require a good storage and a good analytics algorithm, and Hadoop provides both of them, right? So Hadoop gives us a distributed file system, which we call as HDFS, Hadoop Distributed File System, and an analytics algorithm, which is known as MapReduce algorithm, and it has got further implementations in Pig and Hive, which we will discuss in due course of time. So then we discussed this structured versus unstructured. I think it's clear to you now. The slide is important. You must have taken a screenshot. If not, you can take it again, right? And then we have this IBM's definition of big data. Remember the 5 V's of big data. IBM started with 3 V's: volume, variety, and velocity. And then 2 new were added later on: veracity, that is truthfulness of data, and value, that means how much valuable is data to the organization. So these are the limitations of the existing data processing systems that you've been studying in the previous semester, the relational database management systems. The cost factor is there, and it does not, process the entire data. Only a sample of the data is processed. And main problem, it cannot save and access huge files easily, and it cannot perform analytics on unstructured data. That was the limitation of RDBMS. That is why the need to use Hadoop to store and process this big data. Now let's come to today's, let's start afresh now. Let's study something known as a Hadoop cluster. So now your, again, copies should be out, should be noting a lot of things. This one slide would give you many, insights into a Hadoop cluster. So you can consider a Hadoop cluster as, one in which is based on a master-slave architecture, and in which there is an admin node, a heavy-duty machine, which we call as the admin node, and there are further, commodity machines known as data nodes, right? So you can see the configurations for admin node. You can see the configuration for admin node and commodity machines. Your admin node basically must be at least a Xeon processor with at least 64 GB RAM. And your commodity machines, commodity machines, the name, it suggests two things, two characteristics. Number one, they are cheap, not very expensive. Number two, they are prone to frequent failures. Okay, this is what you understand by commodity machine. So your commodity machines would be an Intel i7 processor with 1 TB hard disk and minimum 8 GB RAM. So consider your cluster as a master-slave architecture in which there is a master machine known as the admin node, and there are hundreds of slave machines known as commodity machines, or you can call them data nodes also. We'll understand why we call them data nodes. So now this admin node or the admin machine, it has got two daemons running on it. By the term daemon, we mean a process or a service. Okay, just like in Windows we have services. You can see here. What are daemons? They are a type of program which run on Linux or Unix operating systems. They run in the background and respond to events such as client requests, and they are equivalent of services in Windows. So when you have services, different, every process has got a service associated with it. So service and daemons are analogous, right? Okay. So your admin node has two daemons or two processes running on it. First is name node. Second is job tracker or resource manager. Okay. Old name is job tracker, but the new daemon name is resource manager. So we'll go with resource manager. I repeat, admin node has two daemons running on it. Number one, name node. Number two, resource manager. We're just taking, uh, just a brief introduction into a cluster. We are going to discuss each and everything, each and every process in detail, right? And we are going to see them running in practicality. This is just not theory. You'll see each and every name come in front of you when we are actually using a cluster, which we will create on our own, on our laptops or desktops. Similarly, your commodity machines, they have two daemons running on it. One is the data node. The second we can call task tracker or node manager. Task tracker, old name; node manager, new name. So a recap, admin node has two daemons running on it, name node and resource manager. Your commodity machines have two daemons running on it, data node and node manager. Okay. What they do is written on the screen. I won't go into the details since we are going to, study them in much detail later on. But just one short comment that your name node, it stores metadata. I'll speak two sentences. Number one, name node stores metadata. Number two, data node stores the actual data. So your actual data that you're going to store, the huge data, that is stored on the commodity machines, that is stored on the data node. And what name node does is it just keeps a track of that data. So it keeps a track of that data. That means it stores metadata information about it. That metadata information would be that where the files are stored, on which commodity machines, and a lot of other details which we'll discuss in the subsequent lectures. Right now, two sentences just to keep yourself these sentences fresh in your minds. Number one, name node stores metadata. It does not store actual data. Okay, data node stores the actual data, and data node always interacts with the name node whenever some data related operation needs to be there. Data node must be in continuous interaction with name node. Data node stores the actual data. Name node does not store the actual data. It stores the metadata. That is data about data. That is information about the data. Okay. The details would be, there later on. Similarly, the resource manager, it manages the processing of your data. Okay. It just manages the data. It does not actually, process the data. The actual processing is done by the node manager on the commodity machines. And this node manager must be in touch with your resource manager. Okay, a small cluster can have 15 to 20 machines. Yahoo clusters, there are so many clusters with them, and maybe 50,000 up to 50,000 computers in a cluster in Yahoo, right? So those are the practical things. In for our use, what we can do is we can set up a cluster on our laptop. That would be the installation of Hadoop. So when we install Hadoop on our laptops or desktops, we say that we are setting up a single node cluster. You see, there is only one machine, there is no master and no commodity. Your laptop would act as master machine also and would act as a commodity machine also. So such type of installation of Hadoop on a single desktop or laptop is termed as a single node cluster, which we will do at this weekend. I promise you that, right? So any questions for this slide you can please ask. I'm waiting for your questions. Yes, I'm just coming to you. Just a second. Yes, Prabhu.
Sir, please.
Yeah, go ahead. Ask your question. Prabhu, I'm listening. Just see that
Yes,
you're, yeah,
sir.
please ask what you want to ask.
Sir, please repeat the third point of that slide. Previous
Uh,
slide.
this one, this slide
Yes,
right
sir.
now. Yeah, okay. Which one? The third one. Name node stores,
Yes,
manages,
sir.
ye wala, right? Prabjot, name node
Yes,
is,
sir.
name node does not store the actual data. ठीक है, नेम नोड डेटा स्टोर नहीं करता है, वो सिर्फ डेटा के बारे में इंफॉर्मेशन स्टोर करता है. ठीक है, नेम नोड के ऊपर
Yes.
डेटा स्टोर
Yes.
नहीं होता है. ठीक है, डेटा स्टोर किस पे होता है? जो
Yes, sir.
आपके क्लस्टर में स्लेव मशीन्स हैं, जिनको हम कमोडिटी मशीन्स भी बोल सकते हैं और डेटा नोड्स भी बोल सकते हैं. So 2 points. Name node does not store the actual data. It simply stores information about data. Okay, we call it that it stores
Okay.
metadata. Okay, similarly data node, it stores the actual data. Okay, and for that it must be in continuous interaction with the name. It's clear,
Okay,
Prabhu?
sir. Yes, sir.
Yeah, any other questions please? This is an important slide, make sure that you've understood it. Okay, Smriti wants to ask something. Smriti, go ahead. Smriti, please unmute yourself.
Yes, sir. Sir, difference between resource manager and node manager.
Okay. Smriti, resource manager is a process running on the admin machine. It manages your processing. Remember, it
Okay.
manages your processing. It does not do the actual processing. It manages your processing. The actual processing is done by the node manager daemon or the node manager process, which runs on your commodity machines.
Okay, sir.
See, I repeat for all of you that in a cluster, there are two types of machines. One machine, the master machine, and hundreds and thousands of other machines known as slave machines. We call these machines data nodes, simply because the data node process is running on them. And we call the master machine as name node because the name node process is running on that. I think this nomenclature should be clear to all of you. Name node is your admin machine. Why it is called name node? Because this name node process is running on it. Okay. And data node, all your commodity machines or slave machines, you can refer to them as data nodes because the data node process is running on them. Okay. Any other questions? I am still waiting. You must be clear about each and everything. Okay, Varisha. Just a second, just a second. Yeah, Varisha, go ahead.
Sir, you told about that commodity machine, na? 2 points that it is cheap, and second point, what was that second point?
It is prone to frequent failures. ये मशीन है क्योंकि 24 घंटे पूरा साल चलती रहती हैं. That is why even if
Yes, sir.
you buy them new or they are i7 processors, ये कभी भी खराब हो सकती हैं. They are prone to failure. Right?
Okay, sir.
That is why when we study about the cluster, we will see that we are, replicating data across these nodes. So one data is available on multiple nodes, so that if one node goes out of order, then we can rely on some other node. Okay, we'll
Okay,
discuss the
sir.
architecture in detail, then you will understand. Right?
Thank you, sir. Okay, sir.
Yes, Upinder.
Number of name node.
Yes, Upinder, go ahead. Ask your question.
Name.
Upinder, you are not audible. You need to have a better device. I can't hear your question.
Sir, what is name
I
node?
still can't hear you.
Sir, name node का port number कौन सा है?
I can't hear you. Sorry. You need to ask me a bit louder.
Sir, name port number कौन सा है?
Can't hear you. आप मुझे WhatsApp text कर दो. Maybe we can try that. Put your question in the group fast. Anybody else can ask the question while Upinder is typing his question, and I won't be entertaining this type of querying, in group, but for one time only, if Upinder wants to ask something good, he can just put it in our group. Yes, any other questions, or shall I go ahead? If you have understood the things till this point, just give me a raised hand, all of you, so that I may assume that you're not sleeping, you're all with me. Fine. So moving ahead, you can see a cluster looks like this. I'll show you good pictures of clusters. Right now I have these pictures. So it is arranged in racks. Okay. And one rack may have maybe 400, 500 computers arranged in racks. You can just pull out the rack, right? And racks are connected to other racks through switches. Okay, so a lot of good network is required. Okay. Upinder wants to ask what is the port number of name node. So Upinder, we have not discussed about port number so far. Why are you so eager about port number? अभी जब प्रोसेस देखेंगे, जब शुरू होगी और जब उसको करेंगे तो आपको समझ में आ जाएगा पोर्ट नंबर क्या है. ठीक है? You will understand, don't worry. We'll be learning about all the port numbers of all the processes. Every process runs on some port. So when we actually run the cluster, you will see it, right? If it is okay, you can give me a raised hand, Upinder, that you have understood. Shaman Jung, your hand is raised. Okay, fine, Upinder, lower your hand. Shaman, you want to ask something? I'm unmuting you. No, you lowered your hand. Okay, great. So let's come to the next topic, the Hadoop ecosystem, right? An important one, that what all components are present in the Hadoop ecosystem. Uh, you can take a snapshot of these one or two slides, and I'll send you a few PDFs also so that you can understand what the ecosystem components are. So by ecosystem, we would mean that all those components which help to analyze, store, manage your cluster and help in storage and analysis of data. So many things are there which help. So the combination is known as Hadoop ecosystem. So you can see in this picture, very important one, that at the base of your Hadoop ecosystem is your Hadoop distributed file system, right? You can see, okay? And on top of it is your yarn, which is also known as MapReduce version 2, okay? And it is a distributed processing framework. So for your processing, we have the yarn or the MapReduce version 2, the name is. Then there are a lot of other components. There is Uzi, which is known as a workflow manager. There is Pig, which is a scripting language. There is Mahout, which is a machine learning facility. Then R connectors again for your analysis. Okay. Then for your queries, SQL-like queries, you can use Hive. Okay. Then your NoSQL databases, Apache HBase, which is a columnar store. HBase is a very important and famous NoSQL database. Then you have for your configuration management Zookeeper, and for your data ingestion facilities you have Flume and Scoop. We'll discuss each one of them in the next slide now. Have a look at the next slide. Let's discuss each ecosystem component now. Okay. HDFS, Hive, Pig, Yarn, Flume, Scoop, Uzi, Zookeeper, Mahout, and Ambari. Right. So you can see this important graphic, the very good image which tells you how the cluster, how the ecosystem components look like in the cluster, how they are, and what their functionalities are. Right. So let's read them one by one. HDFS and Pig, we are going to study in complete detail. Okay, so whatever is written there would be much clearer when you actually study them. Rest all you should just know what they are and what they do. We are not going to go into much details of the other ecosystem components. In your syllabus for your this semester subject, we'll be studying HDFS and Pig in complete detail. So HDFS is, remember, Hadoop distributed file system, and is used for managing big data sets with high volume, velocity and variety, right? And obviously it is a master slave architecture in which name node is the master and data node is the slave. Remember, keep this in your mind very clearly. In architecture, your name node is your master node, master machine, and your data node is your slave machine. Okay, and HDFS is well known for its big data storage. That is, it is famous for storing huge files, big files. Then Hive is a high-level query language, which is similar, which is used for your query handling, and it is built on top of Hadoop for providing data summarization, query, and analysis, right? And similar to SQL, Hive has got something known as a HQL, which stands for Hive Query Language. Okay. There are certain methodologies, processes in there, partitioning and bucketing for faster data processing, but we are not going to go into detail of all those things. Then Pig is a high-level language built on top of MapReduce. So remember I told you that initially when this big data technology came into picture, there were just two components, HDFS and MapReduce. Now this MapReduce was complex, built on based on Java, and very difficult programs and long programs were there for programmers. So just to reduce that complexity, and make it easy for programmers to work with the queries for data analysis, this big language was designed. It is basically it is based on MapReduce itself. So whatever you do in Pig, whatever command you write, when it runs in the background, the MapReduce command is running in the background. But that is hidden from the user. The complexity of that MapReduce command is hidden. So you can write very easy and quick short programs in Pig as compared to MapReduce, and you can say that the data size decreases by maybe 1/5 to 1/8. Whatever you would write in MapReduce, and when you write it in Pig, the size would be 1/5 to 1/8. Okay, so, and it is also known as a data flow language. It is very well integrated with Python, and it was initially developed by Yahoo. So these are a few facts about Pig, but we are going to study it in much detail, right? HDFS and Pig, whatever is available, we are going to study it. We're going to implement it. Then we have Yarn. Yarn would be doing all the processing for us, okay, and stands for yet another resource negotiator. It is also called as MapReduce version 2. And you see the two major functionality. The previous name was job tracker and task tracker. The new names are resource manager, node manager, and the one third process which runs in the background is the application master. Okay. So remember the yarn daemons. Okay. When somebody asks you what are yarn daemons or yarn processes, you will say two yarn processes: resource manager and node manager. Resource manager runs on the admin machine. Node manager runs on your commodity machines or your data nodes. Similarly, if somebody asks you what are the distributed file system services, so there are three services: the name node, the data node, and then another which helps name node, another process, that is the secondary name node. I repeat, distributed file system services or daemons are three. Number one, name node; number two, data node; number two, secondary name node. And when somebody asks you about yarn daemons, there are two yarn daemons: resource manager and node manager. Fine. So let's move ahead. Yarn also will be studying in between, the process scheduling and all. We'll be studying something about yarn also, but not in much detail. Then we have Plume. If you need to move log data into Hadoop for processing and then back for reviewing, okay, then you require a ecosystem component known as Plume. Okay, so when you're dealing with log data and you're moving log data into Hadoop for analysis, then the ecosystem component that does is Plume. And if you want to do the same thing with your relational databases, okay, log data would be unstructured or semi-structured, but your relational database would be structured. So if you want to move structured data from your relational database into Hadoop for processing and then back, then the ecosystem component which does it is Scoop. Then there is a component Uzi, which is a workflow scheduler system, right? So it does all the scheduling for your processing, for your storage, when the processing would start, when the processed results would be merged. Okay, so it is an effective system and it manages your Hadoop clusters. Uzi, a workflow scheduler system. Then Zookeeper is there for your configuration management of your cluster, right? So whatever services are required, serialization, atomicity of the processing transactions, this is all provided by Zookeeper. Now, if you want to do some predictive analytics on your data, then the ecosystem component that helps you is Mahawk. Okay, it's used by many companies, Mahawk. And then Ambari is designed to make your Hadoop management simpler by providing interface for provisioning, managing, and monitoring Apache Hadoop clusters. So most of these things you won't be able to view when we work on a cluster, okay? Because these are running in the background, but you must have some knowledge about what all they are doing. Okay, so I think that's the end of this slide. So now your questions. If there are any questions, I'll just bring the slide in front. अगर तो question है तो ठीक है, नहीं है तो we can move further. Ecosystem में we don't need to study about detail about all the ecosystem components. We'll study in detail about HDFS and Pig, and the rest all you must be aware what they are for and a few characteristics for each of the ecosystem components. I've already shared two PDFs with you. You can study in detail about the ecosystem components from there, right? So any questions you can please ask. Raise your hands and please ask. Otherwise, I'll start with the next topic, very important one, Linux operating system. You see, Linux we need to learn because our HDFS commands are based on Linux. They are similar to Linux. You've already studied Linux, so it would be a, an effort from my side to just to revise that maybe, or maybe to check how much you know, how much you've learned. Yes, Parth, go ahead.
So what do we mean by integrated with Python? It is totally based on Python,
No,
or
no. Integrated means that you can run this pig with with Python also. When we run it, we'll see it. अभी मैं ऐसे आपको उसकी बता सकता हूँ. You can
okay,
run pig commands in Hadoop also. You can run it in Python also.
okay, so
Similar to this concept is the concept of Spark. Spark is a new faster framework for processing as compared to MapReduce. Okay, so pig is based on MapReduce. Newer version, latest version of processing this thing algorithm in Hadoop is Spark. So Spark, it runs on Hadoop also. It will run on Python also.
okay, sir.
Okay? So there would be an interface in Python also for running pig and Spark. That is what it means. Very well integrated means that you can work in pig, in Hadoop also, and in Python also.
Okay, sir.
Is that okay, Parth? You've understood?
Yes, sir. Yes.
Okay. Any other question, Parth?
No, sir.
Okay. Yes. Anyone else? So I was saying that Linux is important because most of our HDFS commands would be based on Linux. And since you're going to deal with the file system, when you're going to store your big data, you'll be doing a lot of file related commands on it. So since it is primarily the idea to use your HDFS is in Linux, so Linux commands are a must. You must be aware of the Linux commands. Yes, Ritik, go ahead.
Sir, what is bucketing about
I told
that?
you these are processes which enhance your query analysis and optimization in Hive. We are not going to go in detail for that. That's just a characteristic, that is some process which occurs in Hive. So you can just
Okay,
Google it if you want some good answer for it. So we'll be
right, sir.
focusing, primarily on HDFS and PIG. There is a lot of detail in them. Let's hope we can finish it in this semester. Finish it and work good with it, right?
Yes, sir.
Okay. Yes. Any other questions, please? Ritik, you can lower your hand, please. So I think this is fine. Let's move to Linux, right? Now be very attentive. Some of you might think that you know a lot about Linux. Even if you know, it should be a good recap for you. If you don't know, I promise you, you will learn Linux in 2 classes with me. That's my promise. And learning Linux means learning about 50 Linux commands in complete detail, starting from a scratch. You just need to be attentive and you just need to be regular, right? So I'll just give you an outline because about 1 minute and 47 seconds are left. So we'll have an outline here and then we'll discuss it in the next meeting after 2-3 minutes, right? Remember, we are going to have another meeting after this meeting ends on the same link. So let's see now. So first question obviously would be, what is Linux? So it's an operating system just like Windows, or a kernel distributed under an open source license. So the important is Windows is licensed, Linux is open source. And prior to Linux, we had something known as a Unix, which was not free of cost. Okay, it was a proprietary software. Okay, so the kernel is the program at the heart of the Linux, which takes care of fundamental stuff like letting hardware communicate with software. You know all these things. You've studied it in the previous semester. So why do you need an operating system? Simply, whatever activities you need to do, you need to write, you need to browse the internet or watch a video. Operating system is the program which helps you with it, right? It makes your work easier. Okay. Then who created Linux? Linus Torvalds was a person. And Unix OS is a proprietary software, which means that it is non-free software or a closed source software. Okay, and you need to have some license to use it. But Linux by this Linus Torvalds was made an open source software, open source system, so that everybody could use it. I'm going to close this meeting and rejoin in 2 minutes. Thank you. So the Linux file structure, a file system is a logical collection of files on a partition or a disk. Okay, so you see on your system, you may have different partitions, and one partition can have one operating system. Okay, and usually, you would like to have your hard drive partition so that you can use various operating systems on it. Okay, and one file system per partition is always good for the logical maintenance and management of differing file systems. Now, in Linux, everything is considered to be a file. This is a very important point, including the physical devices such as DVD-ROMs, USB devices, and floppy drives. Okay. One more slide, then I go to board. You see directory structure of Linux. So as you know, as in Windows, similarly in Linux, it uses a hierarchical file system structure, much like an inverted tree, okay, with root at the base of the file system and all other directories spreading from there. Okay, so most of our file system, whether it is a Windows or it's Linux, it is in the shape of an inverted tree or an upside down tree. Usually a tree has a root on the bottom and branches above, but in a hierarchical file system structure, the system is like an inverted tree with root at the top and all the files and directories spreading from there in the downward direction. Okay, so in Linux we have a root directory which is indicated by a slash, which contains all other files and directories. Okay, then each file or directory is uniquely identified by its name, the directory in which it resides, and a unique identifier typically called an inode. Okay, so each file or directory is identified by its name. If it is a file, then the directory in which it resides, and then there is a special unique identifier you see, which we call as an inode. Okay, so now I will ask you, I'm unmuting all of you, I'm going to board, I'll ask you, what this inode is. Is an integer number. So I'm unmuting all of you, but be careful. Now given you permission to unmute yourself. If you can see me. Parth, can you see me? Just confirm. Parth is not responding.
Yes, sir.
Okay. Have the room.
Hello.
Can you mute yourself, all of you? My request. Unmute only when you require to ask something. Give me some time to discuss. So this is your the inverted tree structure. And this is the root directory at the top. At the top we have the root directory and all other files and directories are below it. Okay. So my question is that in one of the slides I discussed something known as an inode. So who can explain what an inode is? Since you've studied this subject in the previous semester, can you please, any one of you, tell what is an inode? I'm waiting for your response. Your name first and then your answer. Yeah, I'm waiting. Okay, one simple question. Have you heard about inode before? Yes or no? Ritika, can you hear me?
Yes, sir.
Ritika, have you heard about inode?
Yes, sir.
What is an inode? Can you explain?
So it contains the information about the attributes or the ownership information about any particular node.
What it is?
So like access details of to the
What
file.
it is? What does it look like? How can we locate an inode? Suppose I want to see the inode for a file or a directory. How I can do it?
So by seeing the permissions of it, read, write, and execute permissions.
Prince, can you answer please? Ritika, good answer. Thank you. Prince, can you answer?
Yes, sir.
How can I locate the inode for a file? Ritika has told us that inode contains all the information about the file, its access permissions, and all other details. My question to you, Prince, is how we can locate an inode for a file?
So, so for a file, while the relation of parent-children.
How? So your answers, Ritika and Prince, they tell me that you are not very clear with inodes. You have not worked with it in Linux so far. Am I right?
Yes, sir.
So one more question. Anybody can answer. There is a ls command in Linux. There is a ls command in Linux. I've written it here. An ls command, right? So what is this ls hyphen l? Is for long listing. My question is, what does it display? What are the things which are displayed by ls hyphen l? Anybody can answer. Your name and your answer, please. I'm waiting for your answers. This is an easy question. I'll be discussing all the details with you. Inodes, lists, every command in detail. But just let me first know how much you know. This command,
Display.
ls hyphen l.
Sir,
Who wants to
it
answer your name
displays.
first?
It
Your name
displays
first.
list files and
Your name
directories.
first. Your name first.
Mridul.
Yes, Mridul. Go ahead. ls hyphen l. What it does?
It displays files and directories which is present there.
That ls also does. What is the difference with hyphen l?
Sir, Prince.
Sir, list.
No, wait, please. Let Mridul first finish. Yes.
Sir, it represents the data in list to list files and directories.
Yes, Prince, go ahead. What other
Sir,
students? There are so many other students in the class. Why they are not participating? It's not a test. We're just discussing. So you should add whatever you know. Don't worry that you are not able to answer 100%. Okay. So I want others also to participate. Prince, you can wait, please.
okay, sir.
Yes. Somebody else to answer?
Sir,
Anybody can answer? Yes. Name?
sir, it represents the directories in the long format.
We must know each and everything about this long format, how the files are displayed. Okay, let's make this distinction. What are the differences between these two commands? ls and ls hyphen l. Now it would be easier for you to answer. You can answer, Parth.
Yes, sir.
What are the differences between these two commands? ls and ls hyphen l.
So ls
Yes,
ls
Parth, go
command
ahead.
the ls command lists the directories and files on the current system we are working
No,
on.
no, no, no. Incorrect. इसको भूल जाओ. ये जो आपने आंसर किया है, just forget this answer, right? Who wants to answer next?
Sir, Sunny Sharma.
Yes, go ahead.
Sir, ls do what ls exactly does it show the name of the directories and files, and what ls hyphen l does, it shows all the details about the directory or file, like the permissions, the owner, like the what are the permission, read, write, like this.
Better answer. ls-l is the longer, format for listing of files and directories. So the first entry in it is which tells you whether it is a regular file or a directory. So if it is the first character on the left is the hyphen, that means like this. When it is, it will write like this. These are the first 10 characters starting from left. This first hyphen would tell you that this particular thing is a file, a regular file. There are many different types of files. And if it is a D here, it means that it is a directory. Okay. The next 9 characters in pairs of 3 are the file permissions. Permissions. What are the first 3 characters? For whom? R, W hyphen, R, W hyphen, R, W hyphen. These are the 3 sets, 3 pairs of permissions for the user, the group, and the others. Okay, there is something known as a user who has created the file, then the group to which the user belongs, and then others. Okay, so this tells you that the users and the group can read and write the file, but they cannot execute. So 3 permissions are there: R, W, X. R is for reading, read permission. W is write permission. X is execute permission. So currently, whatever file we are analyzing here is having read and write, read and write, read and write for all the 3 categories: for the owner, for the group, and for others who don't belong to this group. Okay, so there are certain commands through which the permissions can change also. So we also study those commands: chmod, chown, chgroup. All these commands are there, right? So we'll start our discussion now. This is just an overview. So now I will start with the very basic things with you, some very basic commands with you. So you can write if you wish. If you think that they are important, you can write them also. Okay. So let's go with this alias command. The first command that we discuss is the alias command. If somebody is willing to answer, they can answer what it means and how it can be written. I'm waiting for your answer. Those who have answered, they may not answer again. Somebody new. Yes, I'm waiting. Uh, Money, answer this if you know. Money, are you able to hear me?
Yes, sir.
Yeah, please answer. Do you know what an alias command in Linux means?
I don't know, sir.
You don't know. Okay.
Yes.
Ritika? Ritika,
Yes, sir. Yes, sir.
what is alias?
So alias is like we can replace the name of a file. We can use another name.
You can replace the
But
name of a file, you said.
while executing the program, we can rename it or we can use other name.
Uh, not exactly correct. You see, what is an alias? Alias is a nickname. जैसे हम कहते हैं ना राजेश कुमार उर्फ राजू उर्फ बोलते हैं ना alias. Alias is a nickname. So if you want to use a command in Linux by any other name of your choice, you can specify it with the alias command. I'll do one of it for you. Say alias cls is equal to here. Just run this in your shell. Okay, run this in your shell. So now you are saying that I want to use a nickname CLS for my clear command. In Linux, if you need to clear the screen, you use this command clear. Okay, so now you are suggesting that along with this, I'll use this name also. Okay, is this clear? If it is clear, just give me a quick yes, all of you. You write this command in your terminal, and after that, if you use CLS, it will clear your screen. If you use
Yes.
clear, it will use your screen. Both these commands. Okay. So how long would this be active? Friends, how long would this be active? Yeah, please reply, friends.
Yes, sir.
This command, when we set this command, this alias, will it be forever or for the current session?
So only for the current session.
Yeah. So whenever we make some change in the terminal, it is only for the current session. My question to you, friends, is how we can make it permanent? Suggest, please. How we can make it permanent? Uh, Somebody else can also answer. There are so many students. How many students are there, Maninder sir? Just see the participants.
57.
57 participants are there, and I'm just talking to a few students.
Sir, Rohit. Rohit is.
Yes, Rohit. Rohit, अब आप unmute कर सकते हैं. Hand raise की जरूरत नहीं है. All of you can unmute yourself. Yes, Rohit, you can answer. Okay, anyone who wishes to answer, how should I make this change permanent in my Linux environment?
सर बैश फाइल को एडिट करना पड़ेगा.
Who's answering your name? Rohit?
निखिल.
Nikhil Nilatri, right?
नहीं सर, सिर्फ
No,
निखिल.
sorry. Different okay, sir. Nikhil. Okay, Nikhil, you're saying which file?
बैश फाइल को एडिट, बैश आरसी फाइल होता है सर, उसको एडिट करना पड़ेगा sudo कमांड के साथ में, sudo परमिशन के साथ में.
फाइल नहीं होता था शायद से. ध्यान से याद करके बताओ, फाइल का नाम ठीक से याद है? So I'm giving this opportunity to all of you to answer, please. Nikhil, your answer is correct, but your file name is not correct. Remember, what is the file name?
Sorry sir, bash aliases.
Now listen, all of you. There is a file in Linux known as .bashrc. There is a file in Linux known as .bashrc. This is a sort of an automatically executable batch file. Okay, whatever changes, whatever things you write in it, whenever you start your Linux system, they get implemented automatically. Is that clear? So I'll open up this file. I'll open this using some editor, say gedit dot bash rc. So when I open this file, there would be a lot of things written in this file. A lot of configuration would be written in this file. So there I'll just add this line. Okay, I'll add this line, alias cls is equal to clear, by opening this .bash rc file. So sir is saying this is not visible. Okay. So you will open your, through this command, you open your .bash rc file. Gedit is the editor in Linux. There are others also. There is another editor known as Nano. You can use that also. Another editor known as VI. So many are there, right? So you first open this file .bash rc and put this line, write this line in this file. Okay, and then you run this file. To run this file, you need to write this command on your terminal. Source .bash rc. Source .bash rc is to run your bash rc file. Okay. Once you do it, now this command is permanent. To clear the screen, you can either use CLS or you can use clear. That is the alias command. So do you see how you need to learn the commands? You need to learn each and every command so that you understand its complete working. And if most of you are not aware of this .bash rc file, I would say you are not aware of Linux. That's very clear. Similar file in Windows is, can somebody tell me what is a similar file in Windows? If this file .bash rc is a file in Linux for, making changes so that they appear on runtime, what is the Windows equivalent file of this? Anybody can answer. The Windows equivalent file is this.
Emacs.
Auto executable batch file. Okay. The name suggests that this file, whenever your system starts, this file would be run automatically. Whatever configuration is written in this file would be implemented. Similar is your .bash rc file. Whenever you restart your Linux system, all the commands written in this file would be first executed and then your system would be bootable. I hope this command is clear. Alias you can use. There is a lot of power in this command. This is just a simple example. Otherwise, you can do a lot of things with the alias, which I'll give it to you in your tutorials, right? In your assignment. So coming back to screen. Thank you very much, all of you, for being very patient. I appreciate that. Thank you. Now maybe some questions. आज सिर्फ एक इंट्रोडक्शन है लाइनेक्स के लिए, याद रखो हमें इसको बहुत डिटेल में पढ़ना है, ठीक है? We need to be good in Linux. It would help us in industry. Yes, any questions? You can raise your hands, please. I'm muting you all. Yes, now if there are any questions, you can raise your hands. Otherwise, I will proceed. 10 minutes are left, so that would be the last 10 minutes for today. No questions. That's good. That means you are getting whatever I am saying. Okay. Satkuvar, are you there? Satkuvar, unmute yourself. Speak up something. Satkuvar, सो तो नहीं गए? Linux में बहुत काम करना है हमें. Next session and next class we'll have a full Linux session. So I want your Ubuntu to be installed in your virtual box so that you can work along with me. It would be great fun, learning about all the commands in detail with a lot of understanding. Okay.
Okay, sir.
Good Satkuvar. Okay, so this is the directory structure. Read here. Each file or directory is uniquely identified by its name, the directory in which it resides, and a unique identifier typically called an inode. Some of you told me, Ritika told me that inode tells us it contains permissions and all, but you were not able to tell me what it looks like. So inode is an integer number. Okay, inode is an integer number. In one of the bullets, it's written by convention the root directory has an inode number of 2, and the lost plus found directory has an inode number of 3, and so on. So how many of you are aware of what all directories are present in the root of Linux operating system? Raise your hands to answer this question, please. I'm asking you, how many different types of directories are present in the root of Linux directory? In the root directory of Linux, how many different directories are there? So keep this question in mind. You must come back prepared with this answer for this. I repeat the question. How many different types of folders or directories are there in the root directory of Linux? Okay. See now, inode मैंने आपके लिए पूरी डिटेल निकाली है so that you can understand. An inode is a data structure that stores various information about a file in Linux. Information क्या हो सकती है? The access mode, read, write, execute permissions, ownership, file type, file size, group, number of links, and so on. And each inode is identified by an integer number. Okay, and an inode is usually assigned to a file when it is created. So in your most of the Linux systems, the file system in Linux would be ext3 or ext4. Okay. And in such systems, ext3 or ext4, the inodes are created when the file system is created. In other systems like XFS, it is created as when it is needed. Okay, so we will be learning about Linux is based on ext3 and ext4. You must see this when you install Linux or Ubuntu in VirtualBox. It tells you that the file system is ext3. Okay. And if you wish to see the file's inode number, you can do it today if you have Ubuntu there. Just use the command ls-il, okay, and see the output. ls space -i. I is for inode, L is for long listing. Okay, so long listing along with inode numbers. I'll discuss it in detail when we have the next class and the Linux session is there live also. I'll discuss it there. So this was, what I had planned. Now these Linux commands I had planned. So alias is already done. What about this echo command? Let's see some hands raised. All of you are good in Linux? And remember, while you are answering, it's my request to you, don't Google anything. I don't want to see what you can search for. I want to see what you know. Doesn't matter. Once we end our class, once we end a few classes on Linux, you would be totally educated about it. That's my promise to you. So to give an answer, don't Google anything. That's not required, okay? Echo command, you can see the syntax is written echo followed by a string of text. So if I write echo and then after that I write Ajay Sharma, so Ajay Sharma would be displayed on the screen. But echo is usually there to see the path variable, the user ID variable, and other things also. Okay. Then we'll discuss the ls command. There are I've written just three -l, -a, -i. I'll discuss about 10, 12 ls variations with you, and I'll show you how actually you can work with them. Okay. Then there is a cat command which is used to create files. Okay. Uh, Let me ask somebody. Sarika is there. Sarika, unmute yourself. Sarika, unmute yourself.
Yes, sir.
Yeah, Sarika, can you tell me what are the things that cat can do for us? Yes, Sarika, I'm waiting for your response from your side. Cat command, what it can do? This is the basic. You must have learned it in the previous semester. Sajid. Yes, Sajid, you can unmute yourself. Sajid लगता है कहीं चले गए हैं. Okay. Then Narinder Pal, unmute yourself. Yes, Narinder. Can you tell us what is the usefulness of cat command?
No, sir, I don't know.
That's not a good answer, Narinder. That's a basic thing. ये तो पिछले सेमेस्टर लाइनिक्स में यूज किया ही होगा आपने, तो सबसे पहले पढ़ते हैं हम. Not good, huh? Okay, Vishal Palatia.
Yes, sir.
Yes, Vishal, can you tell us what cat command is used for?
So cat command is used to make files, single or multiple file,
Okay, what else?
or to concatenate files, sir.
Very good. What else?
Sir, बस इतना ही, sir.
इतना ही पता है. ठीक है, two good answers. Yash Udewal, you can answer this question. Cat command.
Yes, sir. So
Go
cat
ahead.
command is used for concatenating files, like if we want to access multiple files at a time.
Okay, what
And
else?
then we can use concatenate command.
Is it? Can it be used for creating files?
Yes, sir, we can use for multiple files or single file. We can use it.
Oh, can we create multiple files with one command? Are you sure? We can display multiple
I never
files, I
tried.
would say. Yeah, I think we can display multiple files with cat at a time, but we can create a single file at a time, I suppose. Okay.
Okay, sir.
Yash, can we append to an existing file with cat? जब भी हम cat करते हैं create करने के लिए,
Yes, sir.
it will create a new file. So can we use cat to append files also?
No, sir.
Okay. Ritika, you can answer the same question.
Yes, sir.
Can we append using cat?
Yes, sir. We can append using cat.
How?
Using the uh, indexing operator, insertion operator.
Insertion operator. That is the greater than, double greater than sign, right?
Yes, sir.
Okay, fine. So that's fine. Thank you, all of you, for attending this class very nicely. In our next class, I'll be going through with the Linux commands, and at the same time, I'll be starting the Hadoop distributed file system discussion also. Its architecture and its working, that would be going simultaneously in one class, right? So kindly, if you can revise a few Linux commands, it would be good. And if Ubuntu is installed, it would be great. So thank you very much, all of you. See you all in the next class.